The flip sign, basically.
So it'd be opposite. So it'd be hypotenuse over opposite, I guess.
Mm.
So then, or like 1 over y, right?
Yeah, exactly.
So then, okay, I'm thinking about this. I'm putting the circle on to remember.
Yeah, good. Unit circle is always a good too.
Okay, so 1 over 0 at first.
Yeah.
It's just 1 over 1.
Yeah. That point is still there then. Yeah.
Oh, 1 over, yeah, you can't really have 1 over 0, I guess. So they're just like, is it like this?
Yeah, it's gonna be, if you say it's getting 0, it's gonna be something like this. Getting to infinity.
Oh yeah, up? Is
Yeah.
it like facing up?
Yeah.
Okay.
Yeah. Oh yeah. That's right.
Okay, this kind of makes sense to me once I think about it mathematically.
Yeah. So this is cosec x, yes. Then you time a 2, right?
Anytime a what?
Yeah, because you find cosec x basically, right?
Yeah.
Then you have the time
Oh,
2, right?
-1. Sorry, I forgot to add the transformation. I was just doing like y equals CSX. Sorry, I was focusing so hard on that I forgot. Okay, let's just change. No, sorry, I forgot to add the transformation. I was just thinking about it. I
Oh,
was
you're
just thinking
making
about how to
2.
do.
Oh yes, that's making a
Yeah,
2.
I was
Yeah,
just
that's a good
thinking.
one. Mm.
Sorry, I was just thinking about like.
Yeah, you move down 1 unit.
Yeah, sorry, I was just trying so hard to like do like the original one that I didn't think about like,
Mm.
you know.
Yeah. Mm. Really moving down. Yeah.
Is that more right?
Yeah.
Okay, yeah.
before it's negative 2,
Sorry.
now it's negative
Sorry,
3.
I just forgot to do the transformations. We were so focused on like figuring out the cosecant, cosec.
Yeah. So this is the one. Let's just like have one homework for this. 40. This is we're gonna have only one question as homework. This is page which page is it? Find page. 414. Question 40 is the homework. Let me just do one. I think that's good enough for this.
Oh, 414. Oh, are we doing homework now?
Yeah.
Okay, page 414,
And
question
question
40.
40, yes. And then we can go on.
Don't need to write anything else.
Then we can go on. And then
Oh, okay, yeah.
so this one is, are you taking physics? If you take physics, this is also something you're gonna need it for physics.
I'm taking chemistry.
Okay.
I did take physics in private school though, and I know I'm going to be taking physics like next year.
So anyway, we definitely need this in math too. Let's just take one example and return to do this. If we take to, it's about transformation again. Have you seen this kind of form before? A sine omega x?
Yeah, I have.
Oh.
I don't remember. Sorry, I mean I don't remember the W variable being like that, but I do remember like the same variable. Yeah, it's like it was more like y equals a sine like
Yeah, I like that.
p equal bx plus c or whatever,
Oh
and
yeah,
then
that's good.
plus d, I guess.
Yeah, good.
Not like that.
Then we can go to this one. And I can explain this. This is because of transformation. This A, well, it's just amplitude, right? Have you heard that?
Yeah, I've heard amplitude. I know. Wait, I already know what amplitude period phase shift is.
Oh, great then. This is
Yeah,
also
because
the same thing as we do A, F, like a
yeah,
B,
this is the
X kind of
same.
thing,
This is
right?
the same thing for cosine,
Yes,
tangent,
it's
sine,
all same.
etc., etc.
Hmm.
You know, this I think like the other things that are not cosine, sine, tangent stuff is like the most new stuff I've learned so far. It's like not review.
Okay. So this one is, well, this is basically all like a transformation. So this is just the, well, special case for trigonometry. So anyway, I can just use this. I basically use this omega getting it out. So it's x minus phi over omega, right? So that's why this is, that's why t equals to 2 pi divided by omega, right? This is the t thing coming from. And this is, of course, shifting left and right. If you know that, we can do one. Let's do example 1.
Okay, amplitude.
Pi to the, wait, this one is phi over omega.
What?
This one
What's
is
phi? What's phi again?
phi is basically this, which is this name, which is this pi.
Over omega. Okay. Over. Oh, okay. Okay. Yeah. phi over, sorry, I forgot that bit. Phi over 2 to the right.
Yeah, because I changed it like this, right?
Yeah.
Yeah, that's why. Yeah, this is basically x plus.
Yeah,
yeah.
I know. It's like b times x plus
Yes.
c,
Yes.
whatever. Or minus b, actually, whatever, I don't care. Wait, oh, it's to the right. Oop.
Here it is.
That's around it.
So this is pi over 2. So the entire pi is still the period from pi over 2 to 3 pi over. And you basically shift like pi over 2 to the right. Okay. There is another one. This one is okay. It's cos, kind of similar though. Do you need to do this? Example 2.
Okay, yeah. This one, I kind of think I already noticed, to be honest.
Okay, just as long as you just don't forget to do that 3 pi over 4, I think that'll be okay. Everything else
Yeah,
is
okay.
pretty similar.
I only messed up like once, okay? It's not that big of a deal. I had a 98 in my class.
If you're good with transformation, we can skip this question. This is similar.
Yeah, I know. I'm good with transformation. Yeah, let's skip.
Okay. Next one.
I feel like I could maybe have some practice with like cod and stuff, but not really with like normal sinusoidal. I'm just not. I think the only thing I'm not really familiar with is like the W and the theta or whatever, because like it's so kind of weird getting used to those variables. But like
They also have 5 key points. Are you familiar with this? This is one kind of method too, other than
Yeah, I know that. I'm familiar.
Oh, this one we can take one example. They have the sign like a model for the real data. Yeah, for example, let's see this one. This is month, and this is average month temperature. And if we put all this, of course, we change this into x value and y value. This is the temperature, and this x is all the what's this? So I basically can put all this one in here and get a scatter plot. Is that again?
Yeah, okay.
If I guess we don't really have time to do all this, but if we already have this as a sketch, can we fit a sine function?
Yeah, we could, because that's like already the mountain part, the mountain valley structure.
Yeah. So how do
So
I
like
find the amplitude?
oh, okay. Do you mean from here or from the data?
No, just only from the sketching. We taking from
Oh,
here.
okay. Well, like there's like the midline is around like 20. The midline is around like 26, I think.
Mm.
And here it's around like, so you would like be like 75 minus 26, and then that would be like, and that would be like half the amplitude
Yeah.
equals
Oh, this one, let's see, this is 20.
39, and like 39 times 2 equals
Wait,
78.
39 divided by 2, right?
39. No, because that's like the distance. Why would it be divided by 2? Because look, this is like the distance between like that in the midline, which is the
Uh,
same between like.
uh, hmm. Oh, you
Or
think this
maybe
is
not.
a, you think this is one, you think this is a quarter of the entire sine, right?
Yeah, is it not? Oh,
Uh,
wait. Okay. I see the step over there. Okay, yeah, fine. Divided. So like here.
oh yeah, there. And then you probably want to mark, if it is real, you probably want to mark, if this is 25, this is half that, oh, this is 50, and that's adding another
It's like 20. That's like wait,
37.5.
37.5.
Hmm. And that's probably, then you can find your 30. Hmm. Yeah, just make sure the approximation is right with the scale. With the scale, yeah. And now we find amplitude. What else can we find with the data?
Well, we could find like the period, I guess. It was like the lowest value is like 29.7. Here. Sorry, I don't know why I didn't think, oh, it starts off at the lowest. I figured like I thought it started wait, I thought the sine function would start off at the midline like this.
Hmm.
Why is it like around 29.7 here? Like I don't get it.
You mean why it's like that?
Yes,
This
because
would be the minimum.
logically,
This is the middle.
you mean the midline?
Yeah, it's kind of I think it's eventually because all the lines they have more data. Eventually, what they have is this.
Well, yeah, I guess, but like I feel like without the data, you would think
Yeah,
that it's like,
that too.
I didn't look at the data that hard. Like I just thought,
Yeah, yeah. Hmm.
I feel like you were only looking at it, you would think it's like this,
Hmm.
but whatever.
Hmm.
So it's like around here and like a phase shift, I guess.
Hmm. So what else can we get?
Okay, I guess
Hmm.
it would be phase shifted around like 5 units. It would be phase shifted around like 5 units, right?
Before it's 0, so if I find the midpoint. Oh, shift. Oh, how do you speculate that?
And the period would be like, I don't know, I'm estimating here, but like
Hmm. We normally do the vertical shift, which is the before it's something like this, right? And now it's
oh
basically
yeah, okay,
moving, right?
plus it's like plus whatever the midline is. The vertical shift is whatever the midline is. Plus
Yes,
like
I can
50
add
or
this to it.
21.9 sine something.
I think I can find that vertical shift. That plus 50, right? It's a 73.5. This is the correct one. Plus 29.7 divided by 2, right? That's the midpoint, right? So this is the midpoint. So that's the vertical shift, right? So that'll be your 50 thing.
Yeah.
And then can we find the peers? I think we can find the peers, right?
Yeah, probably. I think the period, it's still kind of hard to tell because like, I only have like like you just said the midline I need to like keep up with the midline and stuff. Like it really looks like it's going to show up like this, like without like any other data and stuff. It really looks like that, It's kind of annoying.
So if that's the case, isn't this kind of repeat itself? So this would be the period, right? So 12 would be the period, right? Kind of.
That looks more like reverse cosine. That looks more like cosine, but like it was like flipped over the. Okay.
Oh, I can. Oh, I do like a horizontal shift too. So this is so T is 12, right? Can I say T is 12?
Yeah, T is 12.
So I can find omega, right? But omega is
Omega is the W.
Yeah, 2 pi over 12, right?
Yeah.
Oh, or I can say 12 is 2 pi over omega, which I can find omega, which is 2 pi over 12, which is pi over 6, right?
Yeah.
So this one is pi over 6.
Yeah, pi over.
Yeah.
Okay.
And horizontal shift normally is the last one you find. Is kind of a little difficult, I think.
It's like around like pi x minus 5. I don't know. I don't do these things in like a certain order. I just do it.
So it'll be like because it's if the period is 0 to 12. Let me think. If the period is 0 to 12,
Pi minus 6 instead.
I guess you divide it in 4 parts, right?
Okay.
Divide it in 4 parts.
Okay, wait, I think there is a problem to this though, because like if you say it's 12, like there's just a bunch of like this just looks like cosine, but it was like flipped a little bit.
Yeah,
like
for cosine and sine, you can do horizontal change.
I know. I'm just saying there's just a bunch of like other variables unaccounted for and stuff, and it's a bit confusing. It's a bit confusing, and the midline isn't like consistent, the midline is also like confusing. So look, what? It's
sine
around
and
it's around
cosine
5.
can be changed.
Okay, divine. Okay, yeah, I just need to whatever. It's fine.
So now what we have without this one, it'll be 21.9 sine saying pi over 6, say pi over 6x, and plus your 50 thing. If that's the case, I can draw this one. Yes, I can actually draw this one, right? It'll be something more like this, right? And I can find the horizontal change by measuring this one and that one.
Yeah, okay, let me count. Let's say this is at 2. Let's say this point is at 2, and this point
Oh, that
is
one is 3. I think that one is 3 because t is 12 anyway. You divide it by 4 is 3.
okay. Sorry, you were imprecise in your graph. I was just measuring it from like what your graph looked like.
I can use algebra. So that's be a 3. It's equals to 3.
And I think this one's around 8, so it would be like -5, I think.
Hmm. This one. This is the highest point, right? This is the highest point.
I think so, yeah. I mean, this one could kind of also be the highest point, but like,
Yeah. Yeah.
Oh, sorry, I was off by a little bit. X -4.
Oh yeah. 4. Yeah, if it is at 5, I can understand, but I should use 8 minus
Sorry.
3, right? If it is 8 minus 3 is 5, or it's 7 minus 3 is 4. Sure.
Yeah,
So that's,
it's a little imprecise.
yeah,
Okay.
this is the real world problem. We won't need a lot. It's just there is a way in real kind of mathematical model thing. So anyway, so we first find amplitude, right? And then we find, you can find this vertical shifting is also not that difficult. And this also omega finding from the period is okay, right? And then you find whatever you have in this kind and find this using period divided by 4. So that's how you find your horizontal shifting, right? Yeah.
Yeah.
Let's just do one. Oh, this is the same way that we just did it. The rest of we can't do. We have to find all the other like website, which is also similar with the first question.
Mhm.
We'll have to do the rest of it. So the homework for this one, you don't have to do the homework, the exercise. The homework for this is only just redo this because this is not the key in this area. So just redo this question.
Redo example 3.
Yeah, redo example 3. Otherwise, we have to calculate, put a lot
Page
into
what? Page what? Redo example 3.
420, example 3. 420, example 3.
Yep, I just wrote it down.
Next one. What is word problem be? If you want, there's so many. Next one, we can go to more about trigonometry. We finished one chapter. Inverse function, you already learned a little, right? Inverse sine, inverse cosine, right?
Yeah.
Hmm.
Also, wait, can I go to the bathroom?
Sure.
I'm back.
Hmm. Let's see. You already learned inverse sine function, right? Inverse function?
It's like the second.
Like this, right? You learned it.
Yeah.
Yeah.
It's just basically the second. I can't say it. The CSC or whatever.
Yeah. So is this
I can't say any of those things. It looks just like the
oh
27.
wait. No, I don't mean that. It's actually an inverse function. Do you know inverse function of sine? Not reciprocal. Not
I
cosine.
think we did it, but I did it, but it was like 2 years ago.
Okay, let me
Yeah, so
say.
I think I need like a refresher, I think. Like I did do it, but it was in like private school when that was in middle school and like, middle school feels like ages away from high school.
Hmm. So this is kind of like this. This is the sine, right? This is the part of the sine, right? This is the inverse function of sine. So you graph it by find the symmetrical
Oh,
with the y
wait,
equals
didn't you
x.
tell me that? Are you sure? Didn't wait, never mind, never mind. It isn't CSV. But
Hmm.
it does remind me of something else you told me about it being like rotated, flipped over y equals x. I can't
Huh.
remember.
Oh yeah, probably something like that. It's the inverse function. I don't have to know much. I just want to know it's reciprocal. It's actually no, it's symmetry from y equals to x. So sometimes I know the angle, so I can find the sine cosine. And now sometimes I already know the sine value. I want to find the angle. This is the way to go, right? Is that making sense? It comes from y equals to sine x. So now it's this. This is the inverse function of that. Does that make sense?
How? Oh, sorry, I just read Chinese. Okay.
This is an inverse function.
Yeah, so it would be like a sine. So sine -1 is
So for example, this one.
wait. So it will be like 1/1 equals
Hmm.
1. Oh no, I'm not sure what sine -1
So
is.
sine, if I have to find it in here, so some sine x equals to 1, right? That sine
Oh,
x equals to 1.
equal to
So
pi over
yeah,
2.
and x equals to the pi over 2, right?
Yeah.
Or I use my inverse function. So this is using sine function to find it, right? This is using sine
Yeah.
function. Or I can use my inverse function. I can find when x equals to 1, my y is pi over 2. Does that make sense? I can also find it there too. Is it making sense?
Oh, wow.
Does it make sense? These two are
Yeah.
symmetrical points. So now I can just say this is pi over 2, right? What sine value is 1? You say pi over 2. And how about this one? You can also use sine to find it and then get it from the inverse function.
Okay, so let me do the sine first.
Yeah. What sine value is negative 1 over 2? There is a domain thing. This is between negative pi, yes, negative pi over 2 and pi over 2. Yeah. That's the simple.
So it'll be like negative pi over 4, I think.
Say 1 over 2. I think it's a negative pi over 6. Negative pi over 2 would be square root 2 over 2 negative.
Sorry, I didn't do them. So I'm trying to think about it by like the graph. Okay, so negative pi over y again.
It's because I know sine 30 degree is 1 over 2. This is a special angle. So it must be around.
Why do you know sine 3 degrees is 1 over
Sine
30?
30
Oh,
degrees.
30 degrees.
Yeah, 30
Okay, you
degrees
meant
is
30
easy,
degrees.
right?
I thought you said 3 degrees, and I was like,
Oh,
what?
30.
Since when? Yeah, that makes
Ah,
sense. That makes sense.
yeah.
Okay.
So it must be pi over 6. Okay.
Yeah, that makes sense. Like mathematically, that makes sense.
Mm. So it's probably a negative pi over 6. And also because we take one part of the sine, basically. You take this part and this part. Wait, I should write a better one. I should take this part and this part, right? Because I didn't take the rest of it out. Otherwise, I have to find it in here too, right? I don't want to take that. And also calculator don't want to take that many. They use symmetry and periods to repeat those, so we don't.
Yeah, I know. I know about the symmetry, the repetition, etc. You said it a bunch of times.
So this is okay too. This is
Yeah.
just from the calculator.
Let me try to do that actually. Okay, so damn it, I don't actually know this.
This one we just.
Oh, okay. How do you figure this out? I know, like like the.
Yeah, we can do that. That's difficult, right? But so we usually have a table
Remember.
about this. We usually have big
Like
table.
I don't. Oh, okay. Do you use a calculator for this?
Yeah, so for this we can use calculator. Right?
Oh, okay.
We put the calculator. We put the table in the calculator, so they can just automatically give us. So you can just find your calculator and do this. So this is okay?
Yeah, so it's okay. I think I could do it with a calculator.
Yeah. And this is probably a negative value anyway. So the result is that one is 0.34. That's the reading, of course. Sadly, if we don't do reading, the pattern is not that obvious. Is it okay about this? Is it making sense? Inverse, basically, right? We see it before.
Okay, yeah, kind of. I think I need some more practice with that, to be honest.
Okay. Okay. And then before we do, remember this is the domain for this part, and this is the domain for that part.
Because that would equal 0.
Yeah.
Because that would equal
Yeah.
0
Yeah.
something.
Because
That kind of makes sense. Kind of. I don't really get it.
because I don't want to know too many of those. I only want to know a part of that. If I
Okay,
want
yeah. Sorry, this is a lot of like new stuff. The other things were like mostly review.
Okay. So this is, remember that they have domain about this. So this is between, if you want to use this, it's between negative pi over 2 to pi over 2. If you want to use this, which means this one have domain is negative 1 to 1. And this one is not a kind of requirement. This is for simply, well, this is for simplifying purpose. So we don't want to know the more. This one, there is a requirement. Sine value doesn't really have that big thing. How about this one? Example 4.
Okay, let me try doing that one. Okay. It just equals pi over 8, I guess.
Yes, because it's in the domain, so we can just totally use it. But
yeah.
How about this one?
Guess it equals 5 pi over 8. Can I see the actual? Let me try to do the actual mathematics behind it. So sine. Oh my god, I don't actually know what that is.
Yeah. And also, you can't really do that because this one is not in domain. The result is not 5 pi over 8. Because this is not in the domain anymore.
It's just Okay, yeah. So
Oh,
pi.
wait, you can change it into domain and do it. It's not like you can't really find it,
Oh my God.
which means you can find something. Pi over 8, 5 pi over 8 is in here. You can find it and make it this one, then you can do it.
So it'll be pi over 8.
I think it's 3.
So 3 pi over 8.
I think it's 3 pi over
It's
8,
like,
right?
yeah, okay.
Yeah.
Why is the domain this though? Can you explain that again? Like
Oh, why
why?
did? Let me explain the second domain, which is easier. See, what's inside this is because sine -1x, this function have a domain. Why? Because before is y equals to sine x, right? Your sine x
Yeah.
can only be, the maximum number is 1, the minimum number is -1. So the only thing that you can be is between -1 to 1. Does that make sense?
Yeah, I know.
So this one is okay, right?
Oh, okay. That does kind of make sense. So sine -1 and
Yeah, because that one, this one itself have a domain. So the entire
why
thing.
doesn't it why doesn't it apply to this though?
This one
I
is
don't
not. This one is
I
not because limitation. This one is because simplification. Because we don't want to know the rest of it. It's too much. Does that make sense?
Education. Okay.
It's
You
like
just
a.
don't want
I
okay.
don't.
Can you
Yeah.
walk me through how this works like algebraically? I
Which one?
kind
This one?
I this both of them.
Okay.
Like how did it turn out? I don't really get that.
Yeah. For example, if it's
I want
sine -1, saying it's sine pi over 6, which is
30
one over
degrees.
2, right? 30 degrees, and then it turned out it's pi over 6, right? Because
Yeah.
it's
You
sine
show me
-1 over 2, we just did it, it's pi over 6, right?
Oh
See?
wait, okay. Let me like can I see this? Can I think about it again? Okay,
Sure.
sine
You should think
minus
about it.
1. Oh, okay. I kind of get it now.
Yeah. And why they
So it's like
limit it
1.
into, yeah. And
Yeah,
why they
okay.
limit that? Why they limit it? For example, if we do not limit it, if we can try, if it is a sine, for example, if it is a 5 pi over 6,
Yep.
he wants you to do sine -1 and sine pi over 6. It's the same thing. Does that make sense? It's the same thing. So he doesn't want you to remember this one. He only wants you to remember this one. I mean, pi over
Yeah.
6. So because they think it's equivalent, you don't have to put it in there. It repeats itself. Does that make sense?
Yeah, okay.
So this one is you have to, and this one is for simplifying. So that's why this is 3 pi over 8, right? Does it make sense? This one? B?
Yeah, okay. Wait, can you show me the process again for like the other one so I can just reread that? Like
For B?
the pro no for like the this thing. Can you
Oh,
like return it to the not erased format?
what do you mean?
Can you explain why? Can you explain like how something greater than this would work again?
Oh, okay. So sine -1, saying it's sine 5 pi over 6.
Okay.
So if it is sine pi over 6, I can find the sine in here. So this is still 1 over 2, right? So sine -1. So this one is 1 over 2 anyway, right?
Yep.
So it's 1 over 2 anyway. So this, if I follow this in there, there should be pi over
Oh
6.
yeah, it's like a bunch of different things. Like it'll be pi over 6, it could be
Hmm.
3 pi over 6 or something. It
Yeah,
could be
yeah, yeah,
it could be anything.
yeah. We can just go
Well, it
on.
could be 3 pi over 6 actually. That's
Hmm.
stupid. But it could be 9 pi over 6.
Yes. This keeps going. There's a lot of intersection, right?
Yep.
Hmm.
Yeah, yeah, that makes sense. I understand now.
Okay, and also the same series, so that's why it's 3 pi over 8, right? How about B? Gotta be
Yeah.
careful. They have a little domain. Hey, where's the question? Oh, wait, here. This one, example 5.
Oh,
What is it? 5.
0.5, right? And
Yes.
1 point, let me think. What's 1.8 would be like around. Okay, so this is 1/2, so that's within, and this is 9, not within. And it has to be within like, okay, 1/2 is like pi over
Hey,
x,
see,
and
this one has a domain.
oh. Oh
It's,
yeah, yeah. Sorry, sorry. It follows different rules. Okay,
yeah,
-1. Oh, it's still over. It doesn't work.
yeah. So this one really doesn't really have anything.
Sorry, I got confused with the other one's domain. It's
Yeah. So the different form, they do have their corresponding thing. And of course, this is inverse cosine action, right? And still negative
yeah.
1 to x. And this time they want 0 to pi, which means correspond to that is this. And this is 0 to pi. And if we want to draw it, wait, this is the one. This is 0 to pi, right? This is difficult to find symmetrical. See, this is 0 to pi. And if you have y equals to x, and you gotta find it, well, I used to do this, and then do that, and then do this, and then actually do this, and then do this. Does that make sense? It's difficult to find a reciprocal. It's difficult to find a symmetry with this. And this is difficult for me. Does it make sense? If I have this is the inverse.
Yeah, okay, you
Cosine.
just like you yeah. Wait, can I look that again? You just scroll past it really fast.
Huh.
Okay. Okay, -1. Okay. Yeah, okay, that's normal, and then it's there because why is it like 1? Why is it like pi? Why is it like pi up from 1?
Uh, you mean y is
Why
0 to pi?
why is this variable like that?
Which one? Can I mark it? Oh. Uh, well, basically is because this one is pi -1. So you reverse that thing, right? That's how you do
Oh,
inverse function,
okay.
right?
Yeah, yeah, sorry, I just didn't see that. That makes sense.
Hmm.
That
I think this
it's
is difficult. This inverse function graph is difficult.
yeah, yeah, you have to think about it more than the Y one. The Y one, like, it's like you just rotated it over. It's like here,
Yeah,
here,
yeah, yeah. That's making more
whatever.
sense. So this one is I can do point by point though. So this is a 1. I make a symmetrical point with y equals x. That would be this one, right?
Okay, yeah.
Tile or
Yeah,
two.
sine, yeah, like if you do it to the power of -1, it's just reversed. It's like
Hmm,
y is x and x is y. Okay.
hmm.
Sorry, I know I'm repeating stuff we already know, but
No, no, no. It's okay. Let's do 6 then. Find exact value for this.
okay. So that would be 1, I think. The
Uh,
original 0, this one is 1, I think.
I think you mean cosine 0 is 1, right? Cosine 0 is 1. Now what this means, if I draw the cosine, it'll be something.
Oh, wait. Yeah. Sorry, I was just thinking about it in like terms of like y and cosine equals x sorry, I was thinking about it in terms of like y and x. I was like, oh, cosine is x, sine is y, and then I was like, oh, this, and I was looking at this, and I forgot that this was like supposed to be cosine. Sorry.
Yeah.
Yeah, sorry. It takes a second to like compute all.
Yeah.
I don't know.
So what's cosine value is 0, right? This is cosine x. I mean, this is x. This is cosine graphing. So this one would be pi over 2 eventually, right?
Yeah, eventually pi over 2 or whatever.
Or you remember the other graphing, which is more difficult, probably.
Yep.
If you remember this one, you can say what making 0 in here, so it's also pi over 2. Wait, oh, it's there. It's this one. That's why it's more difficult. Don't use that one. We're gonna use calculator eventually anyway. How about this one? Still using the graph that way? No, cosine x. Use cosine x.
Oh, yeah, okay. Cosine x. Wait, so like this value is like the value of like
Y. Cosine x y.
sorry, run that by me again?
So if you draw it, this is cosine x, right?
Yep.
And this is when cosine is negative square root over 2 over 2.
Okay. I thought like the y, I thought it would be like y equals cosine x. Like I
Yeah,
thought it was
sure.
like,
Sure, that too. Y equals
which one is
cosine.
it?
So this is y equals cosine x when y is negative square root 2 over 2 over 2. Does that make sense? And I find x is the
But
same thing as this one. That's why that's called inverse function. We're using the original function to think about it. Does that make sense?
sorry, okay.
So this cosine -1 is asking us when a cosine value equals to negative square root 2 over 2, what is your x, right?
Yeah. Okay, so y is so okay.
I'm
Yeah,
finding,
that makes sense
I'm
ish.
finding it in here, right? Find it in here.
Yeah, I don't actually know the exact value. I feel like you need to calculate over that.
Well, square root 2 over 2 is actually from pi over 2.
I know. It's all from pi over 2, but does that work? Does that work here? Wait, does it work here? I'm trying to think about it. I think it does. Okay, so that would be like let's see what
Oh, the unit circle is also convenient too.
okay. let's just say 3 pi over 4.
Yeah. Or you just go there, right?
Yep.
Yeah,
Sorry, it's just it's confusing to wrap my head around.
yeah, it is. So you have to say it. I
I
would
still
say,
don't really, to
hmm?
be honest.
You still
I
don't
still
get.
don't really get it.
So that's why you have to tell yourself what's the original. The same thing as you. I think you make an example about something and you wrote it there. So which means you make an example. So for example, the very beginning of the inverse function of cosine or sine is this: y equals to sine is the original function, right? This is the original function, right? Then we turns out we say sometimes I know sine x is square root 2/2. And I want to say, what's your x then? This is the thinking about how we get this function, right?
Okay, so sine. Okay, so if y sine x equals pi root. Okay, yeah, it kind of makes sense when I think about it like that. That would be x would equal like out of 2. X would equal. Wait, what am I saying? X
Pi
would
over 4, right?
equal pi over 4. Yeah.
Yeah. So
Kind of
this
makes sense
is
when I think about it in the original stuff. I feel like I'm kind of like, well, I guess I'm not like rusty with it, but I'm like, it's just kind of weird to like put that and also like
yeah,
invert it at the same time. Think
yeah.
about both things and like
And
because like
also,
I keep forgetting like how
yeah.
to actually do the original graph.
Oh, also with this, I can also do with this one, right? The graph, the table here also shows.
Oh
Sometimes
yeah,
you know
that's really
x.
helpful.
Yeah.
That's really helpful. I need to
Mm.
remember it because I don't know why. Like I'm good at this stuff. I'm good at like the sine, cosine, the tangent. Well, actually
Yeah.
not tangent. Sine and cosine graphs.
Yeah.
But then like I just inverted gets introduced and I'm thinking about that as well as it and it's like
Yeah.
a mess.
Somehow, if I know cosine and I want to find sine, this is how inverse function comes out, right?
Yeah.
So that explains this is why is 3 pi over 4, right? Oh, this has something with the sine thing too.
Oh, okay. It's the same thing before but with different domain.
Yeah.
Why is it 0? Oh wait, because x 0. Okay, I'm thinking about this. Okay, yeah, and okay, I kind of get it.
Yeah, it's
Kind of.
making sense, right? It's because
I don't know. I still don't really get it. I still don't really get it.
before, why sine is that? Because I want to include positive value and negative value. And
Okay.
so that covers it. And with cosine, I want to do it with this entire thing. If I want to take the original, the before one is negative pi over 2/2, then I only take positive value. It's not complete. Does that make sense?
That doesn't make sense.
But it doesn't make sense.
Yeah, what are you talking about?
So I'm saying y before is
But why
negative.
is that relevant to this?
I thought you asked.
Negative.
Before is this, right? Sine. They asked this. X is
Yep.
greater than this. And now with the cosine, it's just use this thing. Right?
Yeah, I know. I'm just asking like why is it that? Like because like 0 I try can you just run me through like the steps of like the whatever, I'll just do it myself.
Well, explain why this changed from here to here.
Just like explain it in general. I feel just like explain it, yeah, explain this. I feel like sometimes you just tell me like formulas and stuff and then I'm just like supposed to like get them and then I don't really understand like the logic behind them.
Wait, you don't know and the logic about this? How about the before? Is this one okay? Is this one okay? Because I give this, I thought you understand this one
Sorry,
before.
sorry,
You
my iPad, like my iPad's like Bluetooth connected to like some AirPods by accident. What were you saying?
Oh, I'm saying that. How about this one? Do you understand this one?
Yeah, I get it. Sorry, I just wanted. Sorry, I understand some of it. It's just like sometimes it's just like I just like. Can you run me through the domain bit? I understand how the cosine thing works. I just want you to like run me over the domain bit again and why it is specifically like 0 is lesser than or equal
Yeah.
to.
So let's look at the cosine graph again. So this is a cosine graph, right?
Yeah. I mean,
Well,
it
before it's
doesn't.
all real
Oh,
number is
it
okay.
looks more like oh my God, my pen thing won't work. Oh
Right?
wait, it's because I don't have Bluetooth on. Give me a second.
Because I have pressed this thing.
Okay, yeah, okay. So it's like okay. So usually I see it more like this, but whatever. Okay, so 0, 0, 1, pi over 2.
Yeah.
Oh, okay. I think I kind of get it now. It's just a repeat. After that, it's just a repeat of
Yeah.
like
We don't
1,
want to
0.
repeat. Yeah.
Okay, yeah. Sorry, I just needed it to be like written out and like because it's like kind of hard to like keep all this stuff straight, and it's like sorry, I keep thinking it's like, but like it's just hard to keep all this stuff straight, and like if you like keep slipping up and stuff.
Yeah. Yeah. It makes sense.
Like it's like I need to memorize all these formulas, and it takes a moment to like remember like the logic behind them,
Yeah.
like what, like how, like that graph
Also,
actually.
because this is a simple number. 0 to pi is the simplest number in the
Yep.
well,
It's like it just repeats over and over again after that.
yeah. And let's see. And then use some of this. Oh, let's do example 8 then. Use whatever the graph gives us. Like the formula. Let's do a here.
Okay, I think I can do this.
Yeah. Really fun. Okay.
I think this is around it. I try to like round. I try to like the round the other ones that were outside.
Hmm.
Well, not round, but like replace.
Yeah, if this one is between 0 and pi, that'll be good, right? But I can replace that cosine negative
Oh,
2 pi
we
over
can't.
into some cosine.
So just is it not available?
I can find it in the graph. If the 2 pi over 3 is in here,
Oh, you can find it.
I can find it's a positive, right? It's inside the domain then.
Okay. You need to find its positive counterpart. So I just needed to find the one that was closest to it. Like,
Yeah,
so I thought that would be 0.
yeah. This one is basically here, right?
Okay, that makes sense.
Graphing is always the key for this.
Why is this one 2 pi over 3, but the other one it was like 3 pi over 8 for 5 pi over 8 or something?
Oh, that one is I think that one was which one's that?
That one was sine.
Let me see. There's the yeah. So because our domain is negative pi over 2 and pi over 2, right? So I can use that. So I
Yep.
can find the
So
sine
we find the
graph.
one that's closest within the domain. But why then it? Let me think. Would it be? Oh wait, no, it wouldn't work for if it was a counterpart either. So I guess you just have to find the closest one. Yeah, that makes sense. That makes sense. If it was a counterpart, it wouldn't work either. So you just need to find the closest one, and it would be better if it was like the positive counterpart or the negative counterpart or whatever. The whatever you call it, from which one is.
Yeah, so this one is 3 pi over 4, right? This part is 5 pi over 8, 5 pi over 8. So the rest of it is 3 pi over 8, right? So, and because the symmetry thing, right? This is a symmetry. So this one must be 3 pi over 8. So, and so this one, I can change that into this one, into this one. And because this one is in the domain of that formula, so that I can just use it directly.
Yep.
Kind of similar things in here is what we just did it, right? 2 pi over 3. How about D?
Okay, number D. The closest within there is probably 1. Or like, let me think. What would produce the same value? Okay. Pi would be cosine pi. Cosine negative. Cosine pi is
Not cosine pi, it's cosine value is pi.
right. I'm trying to figure like, okay, so it'll be negative. So that would be -1. And then like, okay. And then like, I guess cosine, I guess the reverse of that. Okay. So that would be pi minus 1. So I guess cosine -1. So that'll just be pi. I guess
Hey,
-1. I don't know. I don't.
this one is the domain problem. If it is
Yeah, I know.
before,
I know it's the domain problem. I'm just trying to
you
figure
don't
out
have
like
to screen.
as we're trying to figure out whether it's 1 or it's like or it's like -1 or whatever. And like I put 1 at first, but then like you told me to redo it. So I feel like that's wrong. I don't know.
This one is, we can return to cosine -1x. This kind of function have a domain which is x between -1 and 1.
Yep.
And same thing as it here. So this one is pi, which is 3.14 something, which is out of the domain, which means it can be done.
Yeah.
Yeah, so we got nothing from here. Right? Same thing as that sine thing, right? It's just out of this domain and we can't do it.
Okay, can you show me that again?
Oh, it's because for this one, is it making sense? You have to be between -1 and 1.
Yeah, I know that. I know the domain thing. I'm just trying to, it was just kind of hard to figure out how to find an equivalent to pi.
But this one, pi is not inside -1 and 1.
I know. I was just trying to figure out like how I could make it within that.
Yeah.
So is it just not available? What is it?
It's because cosine -x, when y equals to cosine negative, even this inverse function for cosine, you can't really find it when x greater than, oh, it's, you
Oh,
have to be between that.
So it's just not available?
Yeah. It's because
Well,
you're
you said
coming
that. Well,
from,
you said okay. Yeah, sorry. You said that you could like round it to like the version that was like available within it last time. So I thought that maybe it could work this time as well. So
mm, not in here. So is D okay?
yeah, it's fine.
Well, if we have, where's the table? So this table shows the relationship between theta and cosine theta. So we can find something about the inverse cosine, right? You can imagine I can also have the same thing with tan, right? So this is theta, I can have a tan theta. And I have all the value for tan theta. And I reverse that, that's the way I have inverse of tan, right? Does that make sense? So in the same spirit, I can have inverse of tan. So this is an inverse 10. Is it making sense?
Yeah.
Similar is this. They're all kind of similar. And this one also have a domain. Oh, domain is okay, this one. Well, the range is kind of is between negative pi over
Oh, the
2.
tan. So it's so okay. Okay, so like the y equals tan minus 1x. Okay.
Mm.
Okay. Let me think about this. X equals tan y. Oh god. Yeah, okay, so let me think. What if tan was 1/2? So then tan, God, I can't think about this. I don't know what this is. And tan pi over 4. What if it was tan pi over 4 and then tan pi over 4 was uh yeah, I'm trying to substitute
Yeah, that's good. Example is nice for this.
4 and then so then it would be like x equals 1, I guess.
Yeah,
Okay. That makes sense. Yeah, and I understand the domain, the range.
mm. So
Well, I understand both.
yeah. So I can also use the table thing, right? If it is 0, 10, if this is theta, 10 theta is 0. If this is pi over 4, that'll be 1, right? So on the other hand, I can ask if, well, if your 10 is 1, then I can find the theta is pi over 4, right? This is how we use inverse function as before, right? Does that make sense?
Yeah, okay.
And oh, this is the graphing. This inverse function is still inverse function. I can still use that rule of how to graph it from y equals to x, right? This is your 10. So
Oh,
if you
also
do,
there's also like 2 more minutes of class. Should you be assigned like the last of the homework?
oh, okay. We did the inverse cos and sine, and maybe not inverse tan, right? Okay, just inverse sine. There's 446 from
Okay, page 446.
yes. Inverse function. From 13 to 24
Okay. Anything else?
and 33 to 36. And let me see more. Oh, there's a little bit more. From 45 to just 45, 46. And 49, 50.
Okay, is that it?
Yeah.
All right, yeah, thank you.
Thank you. Have a good day. God bless you. Bye.
Oh, okay. Bye, thank you.
Bye.